Hello and welcome to T2 Day 4 of Honors Precalculus. We're going to continue solving trigonometric equations. So for this triangle right here, it's first asking for the triangle where the cosine of what angle is negative root 2 over 2. The cosine of what angle is going to be negative root 2 over 2. So if you remember your trig circle right here, cosine is the x value, and when is the x value equal to negative root 2 over 2? Well, that's this triangle right here, and that's when you have negative root 2 over 2 comma root 2 over 2, and that's when this angle right here is 3 pi over 4. So this is asking what is the sine of 3 pi over 4, and that's just going to be the y coordinate, so that's just going to be root 2 over 2. Over here, it's asking the sine inverse of sine of 5 pi over 4. So what is the sine of 5 pi over 4? So that on your unit circle is when you go all the way around, but you start here and you go, that's pi, and you go pi over 4 more. So it's this triangle right here. So that angle right there is actually going to be this coordinate. So it's pi over 4 plus pi, so it's 5 pi over 4. So that's negative root 2 over 2, comma negative root 2 over 2. So it's asking for right here, when you do this, the sine of that is going to be negative root 2 over 2. So this is asking for the sine inverse of negative root 2 over 2. So the sine of what angle is, negative root 2 over 2. The sine of what angle is negative root 2 over 2. So when you look at a triangle unit circle like this, sine of the point on the unit circle that has a y value of negative root 2 over 2 is going to be right there, which is when you have it at root 2 over 2 comma negative root 2 over 2. So that is negative 45 degrees. So that's actually going to be negative pi over 4 if you keep it in radians. So again, the sine of 5 pi over 4 is, negative root 2 over 2. And then it's asking the sine of what angle is negative root 2 over 2. That's going to be right here, negative pi over 4. So let's solve these next two exactly. So first we need to isolate the trig function as far as we can. So we get 2 cosine of theta is equal to 1 after subtracting 4. So cosine of theta is equal to 1/2. So theta is equal to the cosine inverse of 1/2. So the cosine of what angle is 1/2? Well, their first one is going to be pi over 3. The cosine of pi over 3 is 1/2, but then to get the other one, the other possibility is the opposite of it. The opposite of it is going to be negative pi over 3. And then you add the 2 pi multiples, So when you get two answers here for cosine, it's the negative and positive values. So it's positive pi over 3 plus 2 pi n and negative pi over 3 plus 2 pi n. We're going to do something similar with sine, similar but not quite the same. First, we're going to isolate, which is the same. So we have 3 sine of this thing. So pi over 3 times theta minus 2 equals 0 divided by 3, and you end up with 0 on the right again. So you get pi over 3 times theta minus 2 equals 0. And then the question is the sine of what? Sine of what is equal to 0? The sine of what is equal to 0? Well, the sine of 0 is equal to 0 and every pi after that. So the first thing we know is that theta over 3 times theta minus 2 has to equal 0 because the sine of 0 is 0. So that's the first one. But we also know the sine of pi is equal to 0 also. So or pi over 3 times theta minus 2 has to equal pi. So those are the two options we have. But keep in mind we need to add in the period multiples for sine. So really it's pi over 3 times theta minus 2 equals 0 plus 2 pi n, or pi over 3 times theta minus 2 is equal to pi plus pi n. You do this, 2 pi n, sorry, I missed the 2 on the right hand side here, 2 pi n. You do this immediately after the inverse goes away, before you do any simplification. Now you do the simplification. So you end up with pi over 3 theta minus 2 pi over 3 is equal to 2 pi n, just like this. And then to get rid of the fraction, I can multiply by 3, so I end up with pi theta minus 2 pi is equal to 6 pi n. So then I'm going to end up with, let's say, pi theta is equal to 2 pi plus 6 pi n. Divide by pi, you end up with 2 plus 6 n. And then over here, it's very similar. You end up, let's multiply by 3 first. You get pi times theta minus 2 is equal to 3 pi plus 6 pi n. And then I'm going to, let's say, divide by pi. So I get theta minus 2 is equal to 3 plus 6n, and then add 2 to both sides. So you get theta is equal to 5 plus 6n. So the key thing here is that when you're doing these values here, you have to be very careful. Once you get to this step right here, the sign of what is equal to 0? Well, the sign of 0 is equal to 0, and the sign of pi is equal to 0. And then over here, when you have cosine, remember, you can always see this on the unit circle. If you want the cosine of what is a half, that's the x value. That's going to be this value right here and the one below. So that's why it's pi over 3 and negative pi over 3. For sine, the picture you need to remember is that if you have a certain y value, so let's say the y value was here, and you want to know, it's this theta value, well, it's going to also be that theta value going up the same amount, but you always have to go from the right. So how do you get both this and this? Well, if that's theta, this angle right here to the blue one is going to be pi minus theta, pi minus theta. But in this case, because it was 0, when you do pi minus 0, you get pi. That's why it's 0 and pi. Again, this just takes practice. The other key is you add in the 2 pi n immediately after you get rid of the trig function, and then you do this part, and then you do that part. So let's keep going here and do something similar. So on this one, you get negative 3 sine of 2 theta, subtract 1 is equal to negative 2, divide by negative 3, so you get sine of 2 theta is equal to 2/3. It becomes positive because it's negative over negative. Now this is something you need your calculator for. So you know that 2 theta is equal sine inverse of 2/3. And when you do that on your calculator, you end up with 2 theta is equal to 0.730 plus 2 pi n. We got rid of the sign, so therefore you need to add in this 2 pi n. But remember, on the other side, you have to do the pi minus this value right here. So that value right there is 0.730. So you end up with the other answer of 2 theta is equal to 2.412 plus 2 pi n. So when you're doing sine inverse, you end up having to do pi minus the first one to get this answer right there. So now you divide by 2 and you get theta is equal to 0.365 plus pi n, and you get theta is equal to 1.206 plus pi n. This just takes practice. We'll do this a lot. So let's try D here. We're going to add 10, so you get 25 sine of 2 times theta plus pi equals 20. Divide by 25, so you get sine of 2 times theta minus theta plus, pi, double parenthesis, equals 20 over 25, which is 4 over 5. Now that's something you need your calculator for. So when you do this, you end up with 2 times theta plus pi, like this, is equal to sine inverse of 4/5. So when you do sine inverse of 4/5, there's two answers. So you're going to get 2 times theta plus pi is equal to the answer they give you in your calculator, which is going to be 0.927, and then you add in the 2 pi n. But then you have to do on the other side pi minus 0.927 to get the other one. So that's going to be 2 times theta plus pi is equal to, when you do that out, you end up with 2.214 plus 2 pi n. Remember, the 2 pi n always gets added in after you get rid of the inverse trig function, and that this value right here is pi minus the first one. So now you just isolate. So you get 2 theta plus 2 pi is equal to the same thing, and then you divide, you subtract, it equals the same thing. So 0.927 plus 2 pi n, and then you divide by 2, you get theta plus pi is equal to 0.464 plus pi n, and then you end up with theta after you subtract pi is equal to negative 2.678. Use decimals plus pi n, and always go to 3 decimal places. Over here, if you do the same exact type of work, you end up with theta is equal to negative 2.035 plus pi n. Keep in mind, the biggest thing is remembering there's 2 answers for sine inverse, and the first one, if it's that, you have to do pi minus that to get the second one, and then immediately do this part, immediately do that, and then simplify the left-hand side, then isolate. So let's do the same exact thing, but it's cosine this time. So you get negative 50 cosine of pi over 4 times theta plus 1. We subtract 60, so we get negative 30. Now we divide by negative 50, so we get cosine of pi over 4 theta plus 1 equals 3/5. Use our calculator and you end up with, you end up with pi over 4 theta plus 1 is equal to cosine inverse of 3/5. And when you use your calculator on this, and you're in radians, you're going to end up with pi over 4 times theta plus 1 is equal to 0.9273. And then remember, you have to do that plus 2 pi n, and then for cosine, because it's cosine, you do the negative one of this, so it's going to be pi over 4 times theta plus 1 equals negative 0.9273 plus 2 pi n. Keep in mind, because it's cosine, you just have the positive one and the negative one. Now you literally just solve for theta. When you solve for theta, you multiply by 4 and then do a little bit of algebra, and you end up with theta is equal to 0.181 plus 8n. And then over here you get theta is equal to negative 2.181 plus 8n. Do this carefully. I skipped over some algebra at the end, but that's just algebra 1. You can practice it out and check your work. So be careful here. Cosine, you end up with the positive and the negative value. But for sine, you end up with the number here, and then you do pi minus that number. Very key takeaways.